AI coding tools are everywhere now. GitHub Copilot, Cursor, Claude Code, ChatGPT, and those are just the ones beginning with the letter C. We're told they make us faster, more productive, more efficient. But there's a much more important question that fewer people seem to ask. What happens after the AI has written the code? What happens when the next developer has to understand it? When the code has to be changed? When it has to be maintained? Does AI help with this? Or are we busy creating an AI slop-driven maintenance nightmare? That's our topic for today. Hi, I'm Dave Farley and welcome to the Modern Software Engineering channel. If you haven't been here before, please do hit subscribe. And if you enjoy the content here today, hit like as well. Maintainability is so important because it is maintenance and not the initial development that is the dominant cost in software development. It's largely naive nonsense to imagine that you can develop software once and then never revisit again. Estimates range widely, but it's generally assumed that maintenance costs somewhere between 3 to 4 times more than the initial cost of development over the lifetime of a software system, with maintenance representing 50 to 80% of the total cost of ownership. Most of the money, time, and risk in software then happens after the first version has shipped. This is one of several reasons why developing software that's easy to maintain, easy to change, makes commercial sense, while optimizing for short-term dumb metrics like feature count is a rather silly trade-off. Yet most AI studies stop at: did the software developer finish faster? Did they type fewer characters? That's not engineering, that's measuring typing speed. So when I was asked to help with a pre-registered controlled experiment that actually looked at downstream maintainability, I paid attention. And yes, full disclosure here, I am one of the authors, though I confess that the other people did all of the real work, not me. I helped to contribute some initial ideas very early on, and I helped the researchers to find experimental victims via this channel. Some long-time viewers may remember the episode. The research is now published though, so let's take a look at the findings now that we have evidence on the table. This wasn't a toy experiment. In fact, it's one of the more thorough looks at the impact of AI on software development so far. It involved 151 participants, with 95% of them being professional software developers. This is unusual. Most studies are based on students because they're usually easier to recruit. Our research asked these professionals to create and maintain a realistic Java web application in 2 carefully controlled phases. Phase 1, developers were asked to add a feature to some rather unpleasant, buggy code, some using AI assistance, some not. Phase 2, a different set of developers were then randomly assigned code produced in Phase 1 and asked to evolve it without knowledge of whether it was originally written with the help of AI or not. No AI assistance was allowed in Phase 2. That's the key. We're not measuring how fast the same person works with AI, we're measuring how easy the code is for someone else to change it later on. That's a much better proxy for maintainability and generally for code health. The research was meant to simulate a more realistic, broader view of real-world development in practice and measure the impact of AI assistance on that. Let me pause there and say thank you to our sponsors. We're extremely fortunate to be sponsored here by Equal Experts, Transfic, and Octopus Deploy. Equal Experts is a multinational consultancy built on applying the ideas and techniques that we talk about here to build great software for their clients. All of these companies offer products and services, though, that are very well aligned with the topics that we discuss on this channel every week. So if you're looking for excellence in continuous delivery and software engineering, do click on their links in the description below and check them out. The research that we're talking about here was conducted with the aim of controlling the variables where we could. So the researchers didn't just guess, they measured. They measured how long the next developer took to evolve the code, the objective code quality based on CodeScene's code health metric. There are links to that in the description below. Test coverage, and perceived productivity using the SPACE framework, also linked in the description below. This range of measures is important because maintainability is so multidimensional. There isn't just one magic number, and anyone claiming that there is should probably be treated with a little bit of suspicion. So what did we find? Well, the headline is there was no significant difference between the cost of maintenance between AI and human-generated code. That's interesting, and perhaps not what we might have expected. Code written with AI assistance was no harder to change, no easier to change, no worse in quality, and no better in quality. From a downstream perspective, AI didn't break anything. And frankly, given some of the fear-mongering, that's a pretty significant result. And a finding that, as far as I understand it, is new to this research. Now, here's where things line up more with previous studies. In phase 1, AI users were about 30% faster to get to a solution. Not as extravagant as some of the claims for AI productivity, but not nothing either. Habitual AI users were closer to 55% faster. So yes, AI clearly speeds up initial development. That part isn't really very controversial anymore, though, I think. The real question was whether that speed came at some hidden cost. And in this study, there was no evidence that it did. But there was something else that the study found that was very interesting. When experienced developers, people who already knew what they were doing, used AI habitually, their code showed a small but measurable improvement in maintainability later on. It's not a huge effect, but it is consistent. One explanation is that AI tends to produce boring, idiomatic, unsurprising code. And boring code is good. Surprise is usually the enemy of maintainability. But I wonder if there is more to it that's going on here. What is very clear is AI does not automatically improve code quality. We can't stop caring about engineering discipline. Junior developers can't simply vibe their way to good systems. In fact, the study shows that developer skill matters more than AI usage. This aligns strongly with a message that I have mentioned here before, and that was backed up by the recent DORA research into the impact of AI. Fundamentally, AI code assistance acts as a kind of amplifier. If you're already doing the right things, AI will amplify the impact of those things. If you're already doing the wrong things, AI will help you to dig a deeper hole faster. Tools amplify capability, they don't replace it. There's an extremely good article by Jason Gorman, there's a link to that in the description below too, that explores this idea in a bit more detail, but inevitably I like his breakdown of what doing the right things means in the context of getting the best from AI coding assistance. He says, working in small batches, solving one problem at a time, iterating rapidly with continuous testing, code review, refactoring, and integration, architecting highly modular designs that localize the blast radius for changes, organizing around end-to-end outcomes instead of around role or technology specialisms, working with high autonomy, making timely decisions on the ground instead of sending them up the chain of command. For regular viewers of this channel, none of this will come as any surprise at all. I suppose that this may have inadvertently had an impact on the findings from the AI research. Most of the participants in the study were selected from people who responded to an invitation to participate here on this channel. So they were viewers of this channel, which presumably, or at least I'd hope, means that they were already predisposed to doing a better job of development in this sense. So maybe they were pre-selected from the set of people more likely to do this better job. If you're interested in learning how to do a better job, why not join our mail list and get access to how-to guides, free tutorials, and discounts on training courses for you and your team, including discounts on our 5-star rated Accepted Test-Driven Development with BDD course, which is particularly applicable to working more effectively with AI. The authors of our study highlight two other things that represent the slippery slope towards disaster. First is code bloat. When generating code becomes almost free, the temptation is to generate far too much of it. Volume alone is a massive driver of complexity in code, and AI makes it easier than ever to drown in your own code base. The second problem is cognitive debt. If developers stop really thinking about the code that they create, then over time, understanding erodes. skills atrophy, and innovation slows. This is exactly the kind of long-term risk that doesn't show up in a sprint metric. So here's my conclusion. AI assistants clearly improve short-term productivity, and contrary to a lot of popular opinion, they do not appear to damage the maintainability of the systems that they produce. And they might even slightly improve it when they're used well, but they don't remove the need for good engineering. They don't remove the need for good design and the kind of broad understanding and experience that allows us to produce good design. And they certainly don't remove the need for thinking hard about the problems that we face, how to decompose them into small pieces that allow our AI assistants to do a good job, and how to guide them towards solutions that we are happy with. This compartmentalization through decomposition is the central, fundamental aspect of building software. This is the real technical skill at the heart of what it is that we do. And it is this, rather than the speed of typing code, that differentiates good software development from slop, whether AI generated or not. As always, tools matter, but how we use them matters more. If you found this useful, do hit subscribe and let me know. How are the AI tools changing the way that you think about maintainability? I'll see you next time. Thank you very much for watching, and if you enjoy our stuff here on the Modern Software Engineering channel, please do consider supporting our work by joining our Patreon community. There are lots of benefits to that. To our existing Patreon members, as ever, I'd like to thank you for your support. It means a lot to us and it helps us to carry on doing this. Thank you.